Algebra 2, 11.1, Mathematical Patterns. In this lesson, we'll look at identifying mathematical patterns. We'll use a formula for finding the nth term of a sequence. Some things we'll learn: sequence, term, recursive formula, and explicit formula. Moving on. First example. Describe the pattern formed. Find the next three terms. 27, 34, 41, 48. Well, looks like there's a difference of 7 every time. So, if we added 7 to the next time, we'd get 55. And if we added 7 again, we'd get 62. And if we added 7 again, we'd get 63. So the answer would be B. Okay, 1B. Describe the pattern formed here. Find the next three terms. Okay. Well, 243, then 81, then 27. Well, it's not an even difference, is it? It's not the same number. It's not a constant. So it's not going to be add or subtract. Well, what if we do 243 over 81? What does that get me? 3. What does 81 over 27 get me? 3. What about 27 over 9? What's that get me? 3. Okay, so what would the next three terms be? Well, 9, we know it's going to be 3. Divided by 3 is 3. 3 divided by 3 is 1. And 1 divided by 3 is 1/3. So we're dividing by 3. And the next three terms would be 3, 1, and 1/3. So the answer would be B. Okay. Okay. Next example. Real world connection. I've kind of already drawn this diagram for us. So it says physics. Suppose you drop a handball of the height of 10 feet. After the ball hits the floor, it rebounds to 85% of the previous height. How high will the ball rebound after its fourth bounce? So let's look at this. So after the first bounce, I let it go at 10 feet. Hits the ground, bounces up, goes 85%. Hits the ground, bounces up 85% of the previous bounce, so on and so forth. So initially we were at 10 feet. It drops to 85%. So the first bounce, it rebounds to 8.5 feet. And then the second bounce, it only gets to 7.225 feet because we're multiplying it by 0.85. And then 7.225 times 0.85. So on the third bounce, it's only at 6.4125. Times that by 0.85. And the fourth bounce, we're at 5.22 feet. Okay. So that's us working out a long way. So suppose you drop a handball, and this is the same example, and then just talking it through. So ball will rebound 5.2 feet after the fourth bounce. Okay, just like our example showed. All right, how high will the ball bounce after its seventh bounce? It dropped 10 feet initially. Okay, so, and we know we're going to multiply that by 0.85 every time. So we could say it bounced 7 times, or the height after 7, we could say is this. The height after 7 would be 10 times 0.85 to the 7th power. Okay, because we know we're just going to keep multiplying it over and over and over 7 times by 0.85. So let's see that. So we're going to go 10 times 0.85 raised to the 7th power, and that's going to give us 3.20 feet. So the answer is C. 3.20 feet. What will the bounce be? What bounce will the rebound be less than 2 feet? Okay, well, the easiest way is just take our answer and times that by 0.85. Okay, so 2.72 represents the 8th bounce. So the 8th bounce is 2.72. If we times that by 0.85, that represents the 9th. That represents the 10th. So the 10th bounce, it'll be 1.96 feet. So after the 10th bounce, or the 10th bounce, it will be rebounding less than 2 feet. Okay, hopefully that makes sense, kind of how we figured that out. So you can use a variable such as a or a positive integer subscript to represent the terms in a sequence. So the first term would be a1, second term a2, third term a3, so on and so forth. And then you could have n minus 1. Okay, a n minus 1, that's just the term before the nth term. A to the nth term is just n, and a to the n plus 1 would be the next term. So the nth bounce has a height of 10 times 0.85 to the nth power. Okay. Recursive formulas. A recursive formula defines the terms in a sequence by relating each term to the one before it. The pattern in example 2 was recursive because the height of the ball after each bounce was 85% of the previous height. The recursive formula describes the bounce as an equals 0.85 times an minus 1. So let's just make sure we're clear on this. This is just the term. An is just a term. And an minus 1 was just a previous term. Okay? Make sure you understand that. An is a term. An minus 1 is the previous term. So use the recursive formula. Describe the pattern that allows you to find the next term of the sequence. The term of the sequence are even numbers. Add 2 to the term to find the next one. So the recursive formula would be an equals an minus 1. Okay, remember this is current term is equal to the previous term plus 2. To find the 6th and 7th term, we'd have to find what a5 is. So a5 is 10, a6 would be 10 plus 2, which would be 12, and a7 would be 12 plus 2, which would be 14. So find all the values in the term of a9 in the sequence. So a9 would be a8 plus 2, which would be a7 plus 2, which we've already found out was 14 plus 2, which would be 18. Okay, so the recursive formula has some benefit, but as you can see, it could be tedious because there would be a quicker way to do this. Okay, so find the terms a11 and a15 in the sequence. Well, if you know we're going up every 2, so if I know a1 equals 2, a2 equals 4, a3 equals 6, a4 equals 8. What do you notice in this particular case, the relationship of the n value and this value? What do you notice? Our n value times 2 gives us the answer. So a11, what's 11 times 2 is 22, and a15, well 15 times 2 is 30. So the answer would be 22 and 30. The answer would be D. Okay, so you've always got to be looking for the sequences, and we'll talk about arithmetic sequence or geometric sequence the next section. Okay, so now the spreadsheet below shows the perimeter of a square with sides of 1 to 6 units long. The numbers of each row form a sequence. Okay, so the length, let's go, goes 1, 2, 3, 4, 5, 6. So the length goes plus 1 in every box. Perimeter 4, 8, 12, 16, 20, 24. Well, the perimeter goes up 4 every time. So for the next sequence, find the next term, A7, and the 25th term. Well, A7, okay, would just be 7 for the length and 28 for the perimeter. What do you notice? Since we're adding 1 and 4, the n value tells us the answer. Okay, so a to the n is equal to n times 1 for the length. A to the n equals n times 4 for perimeter. So using that shortcut, the 25th term would just be 25 and 100. So it says in sequence in row 2, each term is the same as the subscript. Therefore, a of 7 equals 7 and a of 25 equals 25. In sequence in row 3, the term is 4 times its subscript. Therefore, a7 equals 4 times 7, which would be 28. And a of 25 would be 4 times 25, which equals 100. So write an explicit formula for each. The explicit formula for the top one, for row 2, would be an equals n. And the explicit formula for the sequence in row 3 would be an equals 4n. So you can see the benefit of knowing that. Okay, so write the first 6 terms of the sequence of the areas of squares in example 4. Okay, the areas of the squares. Okay, well the first area was what? Let's look. The area. So let's look. So the length went 1, 2, 3, 4, 5. What would the area be? So that would be n plus 1. So that's the perimeter. We need to know the area and the number of the sequence. So we know the perimeter and the number of sequence is going to match. So the area of a square 1 by 1 would just be 1 squared, would be 1. The area of this one would be 2 squared, which would be 4. The next one would be 3 squared, which would be 9. The next one would be 4 squared, which would be 16. The next one would be 5 squared, which would be 25. The next one would be 6 squared, so it would be 36. So what are we finding out? All we have to do to find the area of a to the n is just n squared. So the area for 20 would be nothing more than 20 squared. So the a of 20 would be 400. So the answer is B. Write an explicit formula for the sequence from part A. Well, we just did it. It's right there. A to the n equals n squared. Critical thinking. Given the recursive formula, a of n equals an minus 1 plus 3, can you find the 4th term of the sequence? Well, if I don't know where to start, we can't find anything. So the answer is no. Since you don't know what a1 is, you can't really go any further. Okay, that concludes 11.1 video. Please proceed to doing the homework on the next page. 11.1 worksheet 3 through 30, multiples of 3.